When we're talking about numbers that are very, very small or that are very, very large, it can be cumbersome to write them. And so what we do is we use something called scientific notation. So how scientific notation works is it's actually a product of two numbers. The first number is a number that's between 1 and 10. And the second number is going to be a power of 10. So basically what this is doing is it's telling us what the digits are. That's what this first number tells us what the digits are. The second number tells us where the decimal place is. So let's just look at some examples because I think that's easier. So if we want to convert this number into scientific notation, what we would do is we'd go to the first, just to the right of the first non-zero digit, which in this case is the 1. So we'd go right here. So 150000. I would put the decimal place immediately to the right of the first non-zero digit. So we get 1.5. I can pretty much ignore the fact that those are all trailing zeros because that's to the right of the decimal place. So far I have 1.5, but of course 1.5 is not the same as 150,000. I need to move my decimal place in order for this to be the same number. So that's what the second number tells us, the number of places we have to move our decimal place. So if we're starting out with the decimal place between the 1 and the 5, we'd have to move it 1, 2, 3, 4, 5 places to get 5 places to the right to get it to be the same number. So 150,000 would be 1.5 times 10 to the 5th. Alright, let's look at this one. It's the same sort of process. We put the decimal place between the, just to the right of the first non-zero digit, so 2.05 is what we have here. And then I need to say times 10 to some power. Specifically, this is some power, though this is going to be a negative exponent though, because instead of moving our decimal place to the right, which normally happens when we multiply by 10, I want to move it to the left, which is normally happening when we're dividing by 10. And as we saw in a previous section, dividing by 10 is the same thing as using a negative exponent on the 10. So we'd want to move the decimal place 1, 2, 3, 4, 5, 6 places to the left. So this would be 2.05 times 10 to the negative 6th. Now, something like 47, it's almost silly to write it in scientific notation, but we could do it. We'd get 4.7. In order to count for the decimal place, though, we need to move the decimal place 1 place to the right, so this would be 4.7 times 10 to the 1st. 0.006, this would be 6, so we'd move the decimal place over here, but of course in order to talk about the same number we need to move it back 1, 2, 3 places, so times 10 to the negative 3. Again, it's negative because I'm moving it to the left. For 2900, this would be 2.9. And in order for this to be the same number, it needs to be moved 1, 2, 3 places. So 2.9 times 10 to the 3rd. And here, we'll go 1.005 times 10 to, let's see, 1, 2, 3, 4 places to the left, so 10 to the negative 4th. We can go back, we can flip our roles here. We can go from a number that's in scientific notation and write it in decimal form in the same way. We'd start off with 8.2. I'm going to hold off on writing my decimal place, though. I'm just going to kind of keep track of where it was. The decimal place was here. Multiplying it by 10 to the 3rd is going to be making our number bigger, so it's going to be moving the decimal place to the right. It's going to go 1, 2, 3 places. But of course, in order to actually be able to move it 3 places to the right, I need to have something in there, so I fill in zeros. So 8.2 times 10 to the 3rd is 8200. 1.25 times 10 to the negative 6th. I would need to move my decimal place 6 places to the left. It's a negative exponent, so we'll move it to the left. Well, the first place would be here. Then I start having to fill in zeros. So here's 1, 2, 3, 4, 5, 6. So we end up with 0.0000, 5 zeros, and then 125. You can always double check these to say 1, 2, 3, 4, 5, 6, 6 decimal places over does get us where I put that decimal. Even if it's something as simple as 2, the decimal place is just to the right of the 2. This is 2.0 if you want to think of it that way. But we need to move the decimal place 4 places to the left, it looks like here. So 1 gets us to the other side of the 2, and 2, 3, 4. We have to fill in 3 zeros there. I'm not bothering I almost never bother writing the leading 0 on there. I find when people start writing the leading 0 on there, it becomes really easy to miscount the number of decimal places. So just double check. If you want to put the 0 on there, you're perfectly welcome to. Just make sure you have it, double check your work and make sure you have it the correct number of places over. 5.301. I write it without the decimal place. I'll move it 1, 2, 3, 4, 5. Looks like I need to add on 2 zeros there. This was 530,100.